Hello, I'm Gary Pocock, and this is my Week 2 reflection for the Physics Modelling Instruction online course. This week I'm going to talk about three main things. First of all, I'm going to talk about the activities that we discussed last week in the online session, and then which is the balloon demo activity, and then the sticky tape activity. And then finally I will discuss briefly the sticky tape worksheet that I've worked on during the week. Okay, first up, the balloon demo discussion. Now, first thing that happened to me was that when we broke up into our groups and we had to draw the force diagram, for some reason that I'm not quite sure of, I decided that I wanted to draw a free body diagram with an angled force, a single interaction force representing the interaction between the wall and the balloon. Normally I would have drawn two component forces, a vertical normal force and a horizontal electrical force. And this generated some discussion, and reflecting on it afterwards, I think the reason that I went for the angled force was because I'd recently been reading a listserv discussion that someone posted about the elephant on the ramp problem. Sorry, I'm just bringing it up now. And the teacher reported that he almost had a fight in his class, and it was about this very problem. Some students had drawn a single upward push force to represent the elephant on the ramp. Others had broken it up into the standard normal, perpendicular normal, and friction components. And this generated quite a bit of discussion. And it really got me thinking, because I realized that this is actually quite a deep issue. I looked through the responses, and the response that I really liked was this one here, where the author argued that the friction and normal forces should not be thought of as distinct forces because they are a single interaction. But there is a very good reason why we break this force up into two components, in that we do not have a specific model for this contact interaction force. The only way we can work it out is by breaking it up into components and working with the forces that we do have models for, which is the gravitational force and the spring force. So I thought that was a really insightful comment. Of course, going back to our balloon demonstration, from the student point of view, for most students I would think that the perpendicular and horizontal component forces would be the clearest way to introduce the discussion. Dave did mention that he's had some students draw an angled force, and that could prompt interesting further discussion. Okay, that's right. The second point that I wanted to mention in relation to the balloon demo discussion that we had online was that one of the participants remarked that her students, prior to the electrical discussion, were used of only seeing the normal force appearing vertically in mechanics models. So obviously her students hadn't done ramp problems, and so they just got routinely in the habit of drawing the normal force vertically. And that made me think, how could you avoid that problem happening? And I recalled that, I think in one of Kelly O'Shea's blogs, that she liked to call the normal force the squishy force, or I think it was squishy or squashy force. And I really like that idea because I think it really helps give a microscopic feel for what's happening with the normal force. so that when students are actually drawing it, they should hopefully be seeing the atoms being squashed in their minds, and in that way should be prepared to become quite comfortable with the idea that you can squash atoms vertically, horizontally, or at an angle. Okay, so that's my main thoughts on the balloon discussion. Just a general comment on managing and breakout discussions online. This is a learning experience for me, as I think it is for most people. I've certainly participated in online courses before, both as a teacher and as a student, but I have had very little experience in synchronous online learning, and I'm finding that in the breakout discussions we do struggle to first of all work out who's going to speak first. We're not quite sure how to manage the discussion, and secondly we're struggling to work out who is drawing what on the whiteboard. The thought I had about that was perhaps I really liked the first breakout we did, where the whiteboard was divided into 4 sections, and each of us wrote something in one of the 4 sections. And I'm wondering whether that might be a good way to proceed with all the breakout groups. My thought here is that when we start a discussion on a new topic, perhaps it's better for us to just quickly write down our own individual thoughts in one section of the divided whiteboard, and then use those written comments as a basis for discussion. So in my mind here, I'm thinking of think, pair, share activities in class, where we ask the students first of all to write down their immediate thoughts and then to share it with their partner. I just had the thought that might be a good way to go with these breakout discussions. Alright, on to the sticky tape lab. Okay, so this was again a learning experience for all of us trying to do an online lab, and it was definitely a struggle. It certainly reminded me what it must feel like for a student to try and absorb written instructions and conduct the lab all in one go. It can get very, very confusing, and I confess that I got a little bit confused trying to do this lab, and I had to go away after class, settle down and do it all again. So yeah, that was a good experience because it reminds me what it's like to be a student and how important it is to introduce the labs in class very clearly so the student understands exactly what they have to do, which is why I generally prefer giving verbal and visual instructions rather than handing out lengthy written instructions for in-class labs. Okay, we had a good discussion afterwards about the force diagrams, and there was some debate about what kind of force diagram the question was asking, because it wasn't clear. Were they asking for full free body diagrams, or did they want us to focus on electrical forces only? And that was something that I reflected on in the follow-up sticky tape worksheet as well. And I could see pros and cons for each approach. On the positive side, a full free body diagram reminds the students that mechanics hasn't been forgotten. We are integrating this new force in with previous forces, and we also have to always keep bearing in mind that the net force on a non-accelerating object is 0. On the other hand, the primary focus of this lab and the follow-up worksheet is to develop a new model for electrical forces. So we don't want students getting bogged down with something that they may have only partially remembered from their mechanics course. So the only compromise suggestion I had was maybe focus primarily on electrical forces only, but perhaps require them just once to do a full free body diagram, so we are able to show the students, or the students are able to see how what we're doing in electrostatics connects with what was previously done in mechanics. Now, I have to confess that I did find the sticky tape lab a little bit confusing, and I can see that the students might well do so as well. And that brought to mind a post on the listserv that Frank Nachessa put up last year, which I'm showing here, where he made the same point. He felt that the traditional sticky tape lab was a little bit confusing, and he has proposed an alternative where he uses 4 objects: desk, transparency, foil and ruler, and just uses a base tape to stick on these particular objects. Sorry, he just sticks separate sticky tapes on each of these objects, and then looks at the forced interactions between the sticky tapes. So I like that idea. I haven't tried it out yet, but I'm going to try it out and see if I can use that rather than the one we went through in class. I also like the idea that Matt mentioned in class of summarizing the force interactions in a table. So what I did was I grabbed the table from the I've created a table, but for Frank Nachessa's experiment, and I'm thinking that's something that I might try. So I've got some notes for myself there. As I said, I haven't tried it yet, but that's on my agenda. Okay, and the final discussion we had in the online course was on the thought pages at the end, which I thought were a good follow-up to the actual experiment. The only query I had, I haven't got that one up here, was about the polarization diagrams at the end. Hang on, let me just see if I can quickly find it. Where's the lab? Okay. Nearly there. Right, these diagrams here. I mean, this is a very good technique, and this is a really nice way of introducing polarization and getting the students used to the idea that a neutral atom can have an uneven distribution of charge. But I've been really thinking lately about how these charge diagrams that we draw in electrostatics can be misleading to students in a number of ways. And it just concerns me a little that we're drawing a single large atom. I know they emphasize it in the question, we're drawing huge atoms, but the huge atom fills the entire paper, and I can see students getting the idea that the entire paper is polarized right from one side to the other side, rather than appreciating that it's only on the surface section near the tape that the polarization is occurring. So that set me thinking about how we could possibly modify this diagram to make that a little bit clearer. And that leads me on to my next topic, which is a sticky tape worksheet, and I'll just bring that one up, my responses there. And just over here is my very modest alteration to the polarization diagram, which is to make the sheet of paper wider than the actual atoms themselves, so that we're emphasizing here that the polarization is occurring on the side of the paper that is closest to the charged tape. I haven't tried it yet on the students because I'm just thinking about these things now, but I'm hoping that will help. oh, I'm just running out of time.